Today we're looking at a polynomial function. The polynomial function b of x equals x to the third plus 8x squared plus 5x minus 14 has a known factor of x plus 2. Rewrite b of x as a product of linear factors. First, when we're looking at this, we can see that it has a degree of 3, which means my highest exponent is a 3. Currently, we're looking at a polynomial that is in standard position without any parentheses. We need to rewrite this so it's in factored form with a product of linear factors. Now, there's a few ways that we can do this. The first way that we're going to try is just using polynomial long division. So, let me set up my division problem. Now, polynomial long division requires the students to remember the process of long division. It looks a little different, but the process is exactly the same. So the first question we have to ask ourselves is x times what will give me x to the third? Now, when I do that, I know that x times x squared will give me x to the third. We want to make sure we line up terms that have the same exponent, which is why I put the x squared over top of the 8x squared. X squared times x is going to give me x to the third. X squared times 2 would give me a 2x squared. Just like in regular long division, we will be subtracting these. When I subtract, x to the third minus x to the third gives me 0. 8x squared minus 2x squared gives me 6x squared. And I'm going to bring down my next term. Now I repeat the process. X times what will give me 6x squared. X times, let me get my pen, x times 6x, and it's a positive 6x, will give me 6x squared. So now let's multiply it out just like we did with long division. 6x times x is 6x squared. 6x times 2 is positive 12x. And again, we subtract them. 6x squared minus 6x squared gives you 0. 5x minus 12x gives you negative 7x. And I'm going to bring down my next term. So now what I need to find out is x times what will give me negative 7x. So x times negative 7 will give us our negative 7x. So when we multiply this out, we have negative 7 times x, which gives us negative 7x, and negative 7 times 2, which gives us minus 14. When we subtract these, we will end up with a 0, which tells us that we have no remainder for this problem. Now we have broken down our problem a little bit, because now I know that x plus 2 times x squared plus 6x minus 7 will give us the polynomial b of x that we started with. But I still need to break down this second polynomial. To do this, we can use factoring or the box method. So I'm going to just factor in this particular problem. I have my original x plus 2. Now I need to figure out two numbers that will multiply to get a negative 7, but add to get a positive 6. I know I have a positive 7 and a negative 1. That will multiply to get negative 7, but add to get negative 6. Just to highlight what I'm doing, I'm saying we are multiplying positive 7 and negative 1 to get negative 7, but then we will add positive 7 and negative 1 to get our positive 6. So these would be our linear factors for b of x. If we wanted to look at it another way, we can also do this using the box method, an area model. If I want to, I have to start using let me draw my box in. I know the linear factor is x plus 2. So now, let's fill in what we know. I know in this top box, I'm going to have an x to the third. And I know in this bottom box, that comes from here. I know in this bottom box, I'm going to have a negative 14, because that's the end part of my polynomial. Now, I also know that when I combine these two terms, I'm going to get an 8x squared. When I combine these two terms, I'm going to get my 5x. Now, I don't know what those terms are exactly yet, but I can work backwards to figure it out. So, let's start looking in our box. I know x times something has to give me x to the third. The only possibility there is x squared. So if I fill in my box, I know x squared times x gives me x to the third. I know x squared times 2 will give me 2x squared. But remember, what I have in green, I said was going to add up to 8x squared. That tells me that this upper box has to be 6x squared. Now I know a little bit more of my box. To find my next value up top, I know x times something has to give me 6x squared. So I know this has to be a 6x, because 6x times 1x will give me 6x squared. To get my bottom number in that middle column, I have to do 6x times 2, which will give me a 12x. Now, I know what I have circled in orange has to add up to 5x. So 12x plus what will give me a 5x? I know I have to have a negative 7x here, because 12x plus negative 7x will give me a 5x. So now I can fill in the rest of my table. I have x times what will give me a negative 7x, and I know it has to be a negative 7. So now, just like we previously had, I know that b of x is equal to x plus 2 times x squared plus 6x minus 7. But we are not fully broken down into linear factors yet. I still need to break down this this trinomial. So we can do our box method again. We can fill it in. We need to find our factors. I do know that this will be an x squared, and I do know that this will be a negative 7. What I need to find are two numbers that when I add them together, I get a 6x. So let's start working through this. I know the only two things I can multiply here are going to be an x and an x. That's what's going to give me my linear factors. Now I need to find two numbers that are going to multiply to -7. I know it has to be a 7 and a 1. I know that. But I know one of those is going to have to be a negative number. To figure out which number is negative, we have to look at our next term. In order to do this, I know I'm going to have a 1 in this box and a 7 in this box, but I know that those two terms have to add to get a positive 6. If I were to put a negative sign right here and I added those together, I would end up with a -6. I know that's not right, so let me try putting the negative there. If I have a 7 and a -1, that will give me a positive 6 when added together. That tells me that this 1 has to be a negative. So when I write out all of my linear factors, I know I have the linear factor I was given from the beginning. I know I have a linear factor of x minus 1 that I just found right here. And I know I have a linear factor of x plus 7 as found right here. That would be my final answer written with linear factors.